Hello everyone, thank you for tuning in. Today going to continue the top interview question. And today's topic is a dynamic program. Let's look up the question, climb stairs. You are climbing a staircase. It takes n steps to reach to the top. And each time you can either climb one or two steps. In how many distinct ways can you climb to the top? Not given n will be positive integer. The example have one given. If you receive 2, your output suppose is 2. Explanation: there are two ways to climb to the top. One way is one step by one step. Second way is 2 steps, just climb once. Example 2, input 3, output 3. Explanation: there are 3 ways to climb to the top. One way is one step followed by one step followed by one step. 2 ways is one step, 2 step. 3 ways is 2 step then 1 step. So for DP question, then you definitely need to define a DP array. Then you find the best problem. Then you optimize the best problem and add 2 until to n. Let's look at the hint. Every time the hint actually very useful. So let's look at to reach n step. What could have been your previous steps? So next step all depends on the previous steps. And I have I just recently installed this one. See if I could write in here. Okay, so I'm going to define a DP array. For example, in here it will be n. In this example, maybe I give 5 or 6. See, so you have a DP array where you initiate the array 0, 1, 2, 3, 4, 5, and 6. Eventually you just find return the DP6. Okay, and you're going to find each for DP array. So you're going to solve the sub problem, then eventually reach the bigger problem. So if it is n, if you receive a 0, of course you don't need working, so it is 0. But what happens if you receive a 1? Definitely you only have a 1 because 2 steps you cannot work. And for 2, you have a 2 step. So this will for 3 actually is 1 and 2, or 1 plus 2 is 3. So you actually 1 plus 2. Actually is have a 3 way. But for 4 is previous step, previous 2 step, 2 plus 3. It actually is 5. And you could find it because you have one more way. And 5, it actually is 3 plus 5, so 8. And if it is 6 and 5 plus 8, it is 13. And so the answer will be this one. So this is the key. And so you define DPN position. Okay. So that is the are going to solve by use this problem. If you write a recursive, also exactly the same. You just continue looping until to this one. So you bubbled up. Same way to solve if you use recursive. You also find the sub problem. But in this topic, he said it's a DP problem. So I'm going to use DP to solve it. So if it is a DP problem, then I definitely have a DP array. And because the integer is you going then eventually after you publish it, you just return DPM. So the length is n plus 1, not n, because you actually need to return DPM. And you already see the diagram. If it is n equal to 1, you don't need a loop. Equal to 0 or 1, you don't need a loop. You actually just return 1. He said positive, so won't be and 0, no negative. Then otherwise you just fill out your DP. Like I said, my DP array is built by 2 position ahead, so it is DP1. So you fill out the DP1. You already know DP1 is 1, and the DP2 is 2. And for the rest of all, you just looping it. So dpi, so we are equal to dpi minus 1 and plus dpi minus 2. And if you can't get this one, just go back and see what I drew the diagram. Let's test it, see if I have any syntax issue. It finished, and let's test, and it very fast, 0 milliseconds, and let's check it out. No, submitted. Yeah, it accepted. Thank you for watching.